Good morning, good afternoon, good evening. Thank you for watching this. I want to talk to you about feeding broilers total inorganic phosphor-free diet with phytase maintain normal performance as shown in 4 independent trials. This research is a collaboration between Danisco Animal Nutrition Group of Wageningen University, Department of Poultry Science of Texas A&M in the US, IRTA Animal Nutrition in Spain, and Schotter's Feed Research in the Netherlands. First, it is good to understand that it is very important to be very careful with the limited resource phosphorus. It's a finite resource which we have to preserve also for future generations, and also the price is steadily increasing year by year. But if we look at animal production in general, but also at broiler production, we still see that broiler meat is using several millions of tons of inorganic phosphate each year, and each of this ton is emitting around 750 kilograms of CO2. While on the other hand, we would like to maximize all the phosphorus that is already in the plant-based material in the diets available to save the resource, but also to reduce pollution. The challenge we have is that the requirements of phosphorus of fast-growing broilers, especially at young age, are very high, around 0.48% available phosphorus. While on the other hand, the basal ingredients in a diet only provide for 0.15 to 0.16. So the challenge is, can a phytase release sufficient phosphorus to meet these requirements of these fast-growing birds? So our hypothesis was, if we use proper feed formulation and phytase dosing strategy, we would be able to maintain performance in all plant-based diets without supplementing inorganic phosphate. And to prove that, we did 4 broiler trials to confirm our hypothesis. What was our approach? Of course, you have to have sufficient phosphorus present in the form of phytate phosphorus. We did that by using phytase-rich ingredients also early on in the diet. We aimed for at least a breakdown of 85 to 90% of IP6 using a high efficient phytase. We also optimized our calcium levels, so not too high calcium levels in the diet, also based on limestone solubility. We used a phase-specific dosing strategy, and we stimulated good gizzard development, for example, with the use of 1% of oat hulls. If you want to draw in phytate-rich materials, you see that the brands but also sunflower rapeseed meal have higher phytate levels than, for example, typical corn, wheat, or soybean meal. Also, you notice that there's quite a range of different raw materials measured. This is an average of 1,000 different samples across the different raw materials. There's a range of actual phytate levels in the ingredients. So if you formulate a diet which we want to remove inorganic phosphate, it's also good to measure actual levels of the phytate phosphorus in the diet, or have good values and not just rely on table values. If you look at the industry byproducts, and these are, for example, the brands wheat bran, rice bran, or wheat millings that come from human processing, they're very low price, typically very local, and not suited anymore for human consumption, and they come with high or higher phytate levels. Also, they come with low or very low carbon footprint levels. So by all means, using these kind of raw materials in a diet for broilers can be seen as a very sustainable way of using raw materials. If we look at the methodology overall, we started with 2 small-scale trials with a proof of concept. Then we had a medium-scale trial, and then in the end, a larger-scale trial. With the proof of concept, we had 24 to 26 birds per pen. We have both had a trial with males and a trial mixed sex. On the medium scale, we looked at the potential male and female interaction, and also reduced already the phytate level in the finisher phase. And in the larger scale trials, we've also further reduced our phytate level in the finisher phase, and really had a large number of birds per pen. In all of these trials, we had a positive control with inorganic phosphorus in it, and we had an inorganic phosphate-free diet, which was supplemented with a novel consensus bacterial 6 phytase variant. The measurements we took, we looked at performance, of course, body weight, feed conversion, and carcass yield. Phosphorus availability was judged by bone ash and bone breaking strength. And also we looked at the profitability, looking at the feed cost per kilogram body weight gain. We look at across the 4 different trials. You see here for each of the phases in each of the trials, the phytate phosphorus level in the diets. And what you can see is that the basis of the raw materials was corn, wheat, soybean meal. With an earlier diets, rice bran, wheat bran, and rapeseed meal. And in the last sort of feed research, which was a 3-phase feeding, we had relied on sunflower meal, wheat middlings on the basis of corn, wheat, and soybean meal. So we see we used a variety of different raw materials to, let's say, look at inorganic phosphate-free diets. Look at the enzyme inclusion levels. I will not go in all of the details. You can pause the video if you want to, but typically we had a dosing strategy starting high and going to 1,000 in the finisher phase. We had there were trials with isolanase in the background and trials without, and there were treatments with different levels of downspec for calcium, energy, and phosphor in the diets. This is the first trial at Texas A&M. This one has been published early this year in Poultry Science. So you can pause the video to look at the details exactly on both the raw materials used as on the nutrients we formulated. As mentioned, we checked upfront the raw materials going into the diet, and also we checked on the formulation that we were sure that we really fed the diets we think we were feeding. And it's the same true is for the second trial at Texas A&M. If I look at the IRTA trial, this is where we took in the phytate level in the finisher phase a little bit down. And you can pause again the video to look in details on all the ingredients that we used and also the nutrient levels we formulated towards. And this is the final sort of feed trial, which is the larger scale trial with 820 birds per pen. And in this trial, it was 3-phase feeding, so slaughter age at 37 days. Now for the results. If you look at tibia ash across all the different trials, also at different ages, you can clearly see that there was no significant difference between tibia ash in the inorganic phosphate-free or the positive control. And we both looked at endpoints, but also very early on in the middle. So there you see different time points in time, and also the different trials where we looked at both the positive control in inorganic phosphate-free. One other critical element, of course, when you want to zoom into is the performance early on. What you can see here is that the performance of the inorganic phosphate-free treatment is at least equal to the positive control with inorganic phosphate in it. And the first TAMU trial, actually, the inorganic phosphate-free even significantly perform better, but on average our conclusion was at least equal performance-wise also early on in the broiler's life. If you look at overall performance, you can see that for the 3 of the 4 trials, the inorganic phosphate-free treatment actually performed better than the positive control. We also saw that for all of the 4 trials on the feed conversion. And the feed conversion is corrected for body weight differences by 3 points. Also, we looked at feed cost per kilogram body weight gain, and on average, that was reduced by 4.4% in the range of 2.6 to 6.4. It was based on the price levels at the time these trials were conducted, so 2019, 2020. And we looked with feed print using the normal settings. And that means for EU conditions and without land use change. And with these calculations, it was shown that these diets, inorganic phosphate-free diets, had about 10% less carbon footprint emission per kilogram of body weight as compared to a corn soy diet for EU conditions. So by all means, very good results. So we have shown across 4 trials that it is possible to 100% replace all inorganic phosphate in all phases. We did this with a high phytase dosing strategy, but also using early on in the diet phytase rich ingredients, which we showed is possible to really include in a broiler diet. We were able to maintain bone ash and carcass quality versus the positive control, and this led to less carbon footprint emission, as mentioned. So to summarize, and also if people want to make steps in using this, advice would be to measure the phytate for your raw materials because there's a variance. Have a critical look at your calcium levels. A lot of diets have a higher calcium levels than needed, and lower calcium levels are beneficial to make maximum use of nutrients. Of course, you have to dose sufficient phytase, and the phytase must be effective early on in the gastrointestinal tract. And I would advise increase alternative raw materials level step by step. Don't take it all at once, but do this step by step. But we have shown across 4 trials that it is possible that we have cost savings and are more sustainable in broiler production. If any additional questions, feel free to drop me an email on one of these 2 email addresses. I want to thank you for your attention. And as said, if there are any questions, please let me know.